This is Alex Trent, and this is back with another video of grinding Leetcode. Okay, let's go to Leetcode and find ourselves an easy problem to solve within 15 minutes. If I can't solve it within 15 minutes, then I'm going to look at the solution and try to solve it. Okay, I wonder how many questions. I solved 96 so far, holy smoke. And I solved one hard one. That hard one probably take days to finish. Alright, let's keep shuffling through. Let's keep shuffling through and get ourselves an easy question here to solve within 15 minutes. Perfect. Oh god, I hate 3Ds array. Okay, let's just look at the example first and then go back and look at the description. So let's see. This grid is 1 by 1 comma 2, 3 comma 4, output 14, 17. Here are the three projection shadow of the shape made with the axis aligned plane. So 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. What? Output 17. Here are all the projection shadow of the shape made with the axis aligned plane. Output 2. Grid is 2. Output grid is 1, 0, 0, 2. 1, 2, so 1 and 2, 3 and 4, 3 and 4. 1 and 2, 1 and 2, 3 and 4. So from the x-axis, we are looking at 3 and 4. From the 3 and 4. From the y-axis, we're looking at not 1 and 2. 1, 2, 1 and 2. Here are the three projection shadow of the shape made with the x-axis. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 plus 6 is something. 6 plus 4, that's gonna be 6 plus 4 is 10. 10 plus 7 is 17. Okay, I kind of get it. 3 and 4. 1, 2, 3 and 4. 2 and 4. And this is the top down view, right? X is 1. How come X is just X, Y, the Z? This is not X. This is Z. Maybe they misspelled this or something. Okay. So the top down view, if the array contained 4 elements, if the length of the top down view is just the length of the array. Yeah. And the side view, let's see, 2 and 4. 2 and 4. X view 2 and 4. Okay. So where's 2 and 4? 2 and 4 is this number and this number. Oh, you are given my n by n matrix, so it cannot be. It can be 1 or up to 2 and 3 and 4. It's 3-dimensional figure. Okay, 2 and 4. And this is 1 and 3. And then 3 and 4, which is the top biggest one. 3 and 4. 3 and 4. 2 and 4. 2 and 4 and 3 and 4. What about 1 and 3? Where's 1 and 3 at? This is 1 and 3. Which is too low. 2 and 4 is this number. 2 and 4 is this number. 2 and 4. So the first number is just the length of the array. And this is the grid. This grid is 2. Why is it outputting 5? This grid is 2. Why is it outputting 5? It's only 2 here. Oh, because 2. 1 is the top-down view, right? 1 is the length of array. The x-plane only have 2, and the y-plane have 2. So that's why it's 2. So I split this up into 2, right? So this is x, this is y. This is x, this is x. The maximum of x is 3. And the maximum if I look at it, man. So I just gotta find the biggest number array. This is 3 and 4. That sum is gonna be 7, right? That sum is 7. The sum is 7, which is the y-axis. This sum is 0 and 2. 0 and 2. That's gonna be, how's this 8? Okay, there's 4, but no, there's 2 here. So 1 and 2. Because the height of this is 0. 1 and 2. I don't see how this is mapped out. This index is 0. 0, comma 0. 0, comma 0. So this is 0, comma 0, which is 1. This box right here is 1. 0, comma 0. This box is 1. 0, comma 0. Oh my goodness, this is requiring a lot of thinking actually. So what pattern can I see? Let's look at the description. Each grid is V, I, J, V, okay, blah, 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 blah. Okay, so if it's 0, to find out how many, from the top-down view, right? So let's just look at, make a def top-down view. It's gonna be, let's just call it Z, because we're looking from the Z-axis down. Z-axis. So in that case, we're going to return a number that is just going to be return, okay, for each in grid for each grid for I in grid for j in I. Oh my god. If grid at I and j more than 0, then counter plus equal counter equal to 0, then counter plus equal to 1. Return counter. That's going to give me the top-down z-axis view. So top-down equal to z-axis passing in grid. And we're going to return top-down to see if one of our edge cases passing. Run it. Self.z-axis. I don't think I'm going to solve this in time. This is a very difficult problem. Return top down. Okay. Self secret. Self.z-axis, which is taking self and grid. There we go. For I in grid, for I in range, length, for each. This must be integer or slices. Let's. Jesus, man. For cell in grid, for cell for each in cell, if each 1 0 plus count over 1. Okay, top down 4, top down 1, top down is 2 because we only have 2 here. Cool. So now that we have the top down view, now we're gonna get the side view. So def x-axis. Let's see. The x-axis. That's 2 and 4. How is it 2 and 4? 2 and 4. Well, look at this example. What is the side view? The top view is gonna be 2 for sure because it's 1. Because it's just 1 and 2. This will occupied 0 0, and this will occupied 1 and 1. This will occupy 1 and 1, right? And this will occupy 2 and 1. No, 2 and 2. So it's right here. For looking at the side view, 1. Oh, wait a minute. 1, 2, 3. Yeah. 1, 1, 2, 3. This diagonal is a diagonal grid. But what if 1, 2, and 3, right? 1, 2, and 3. 1, 2, and 3. So diagonally, this goes like this. But what if, right? 1 and 4. 1 and 4. So 1 and 4. 1, 2, 1 and 4. 1, 2, 4. This is 4. This is 1. But right after 1, there is a number 2, which is. So I need to find the maximum. The maximum of the first one, right? And look at the maximum for the second one. That's the 4. So I'm gonna get 4. So that's how the x-axis is gonna look like. Cool. So x-axis is gonna be. Is the x-axis the same thing? No, it's not the same thing. Okay. So for each for cell in grid, counter equal to 0. For cell in grid, taking self and grid. For cell in grid, for counter plus equal to max of cell. And in the end, we're going to return counter. So now we can do x side is equal to self dot x axis patching in grid. Now the dot and the next side. Okay, so we have 1 0, which is 10. Now 4 plus 10. Okay, that's 10. Now we just got to figure out this side right here. So if you think about this, we're looking at it from what angle? If this is that angle, we're looking at from this angle, right? So from this angle, this is 1, this is 1, this is 4, this is 3, and this is 2. We're looking at it from this angle. 2 and 4. This is going to be a little bit more tricky. We have to rearrange the array somehow. So if we're looking at it this way, the 4 is going to be overshadowing the 3. No, this is 1. This is 2. This is 1, 1. And this is 1, 2. Now, look at the x-axis. 1 and 2. 1 and 2 is backward. 1 and 2 is backward. 1 and 2 is backward. I'm having it backward. This is 1, this is 2. This is 3, this is 4. So this side, we're gonna get We're gonna whichever one have the max is we're gonna return that sum. Okay. So now we're gonna have def z y-axis is equal to self and grid, right? Counter equal to 0. Max for cell and grid. No, we're not gonna have that. Let's just have max val is equal to 0 initially. For cell and grid, if sum of cell max val is equal to sum of cell max val is equal to sum of cell count max val equal to sum of cell and max of cell and max val. Now in the 10 we're going to return max val. Now y side is equal to self dot y axis grid, and we return y side on it. Submit. Okay, let's see if that works. Fudge. Okay, what is going on? We're top down, side view. Okay, so why don't we print out y side. We should get 7 for that, right? We should get 7 for that. So let's see what's wrong with it. Zero. Max equal to cell for cell and grid max val. Sum of cell max val. Okay, hang on. Let's print out sum of cell. Run it. I think that is the reason why it's 0 right now. 3 7. Okay. So if it's outputting 3. Oh my god. Max val equal to that. No wonder why. Submit. That should work. Output 7, expected 8. Okay. Wait a minute. So this is 1 2 3 4, right? 2 and 1. I need to find 1 and 2. 1 2. No, I need to find the maximum of each of one of these. So if it's 3 and 4, no. Yeah, I need to find the maximum. So 1 is here. 3 is going to be overshadowing it. So I need to find a maximum and then add that to the array. Okay, hang on. I got it. Okay. Counter is equal to 0. So for cell and grid, counter plus equal to max of cell, and then in the end we're going to return counter. Submit. And that should work. Shit. 6. How is it 6? No. Wait, hang on a minute. No. It's not max of cell. It's not max of cell because this is 3. This is 1. No, for cell and grid. For cell and grid. no, we have to do a for 2 loop here. So we have to do 1. Is 3 more than 1? Is 3 more than 1? True. Keep going until you find the last one. Yeah. So that's gonna be the case. For I in cell length. Okay, let's say counter equal to 0. For I from cell length is equal to each cell length of grid at 0. That's going to give me the cell length. For I in cell length, right? Now we're going to loop through every single one of them for I in cell length. So let's say 1 here, and let's say length for n length is equal to length of grid. For let's say number one for I in cell length, and let's make a new array. No, let's just append to the arrays is equal to this. So every time we get done with this, we're gonna append it to the res. No. Let's have a max variable. Max cur max equal to 0, right? So now we're looping through 1, 3. So that's gonna be for j in length. In range length, right? So we know that the first index for j in length, so grid cur max is equal to grid max of grid at I comma j, right? Because it's 1 here. No. J comma I, because j is looping through every single one of them. I is looping to the first one, 3, 1. Cur max, grid max at gray, or cur max. Cur max at j is equal to cur max. Okay, and in the end, we're going to counter plus equal to cur max, return counter, right? This is taking a lot longer. Okay, in self length, in range. Run a sucker. Okay, that worked. It's only take a couple tries and way too much time. Okay, let's see what the best solution is. Yeah, I'm not waiting. Okay, MC for R in grid, for MC for range, for blah blah blah. You can do that too. Let's see what the next best solution. Okay, top, front, yeah. Zip zgrid for now. What is a zip command? Top command. Yeah, that's basically it. I know that one. For front, it's just the max of row. Okay, that's fine. For side view, sum of max row for row in zip grid. What is zip command? What is the zip command? Take 2 or more data set and zip them together. What the hell is this doing? For row and zip grid. Let me see that. What that's doing. Let me see what that is doing. Run it. One, 3. Huh. 1, 3, and 2, and 4. What? I did not know that. Wait, why is it passing in grid. What? Why we pass it in without the thingy? So that's just 1 and 2. 1 and 2, 3 and 4. But what does that do? The star asterisk. Print star grid. Is that just a tuple? No, I don't know what that's doing. Row at 0. One and 2. That is genius. For row and zip grid. What is this doing? When you use a zip function in Python, it takes 2 or more datasets and zip them together. But why does this? Okay, let's ask ChatGPT. Chat. What is this doing? And transpose it. Holy crap. So yeah, that's how you transpose a matrix in Python. That's genius. 1, 2, 3, 4, transpose a matrix. Okay. Unpack each row of the grid as a separate argument to zip. Unpack each row of the grid as a separate argument. Unpack each row as a separate. What do you mean? Can you show me what the grid is doing? The first row is 1, 2, 3, 4 become the first argument to get zipped up. Oh, okay. So it unpacks it. The first row is 1, 2, 3, 4 because the first argument gets zipped up. So it unpacked the second row and the third row. So now it becomes 147. The first row is 147. I still have no idea. Jesus, that is genius. Whoever come up with that needs to get a raise. That's crazy good. Okay, let's see what this is doing. For R in grid for that's row in grid, MR equal to 0. And this is just a whole bunch of conditional. For I in range of length of R. So that's looping through every single one of them. Looping through if R at I is more than 0, answer is plus equal to 1. And if that is true, if MC at I is less than R at I, MC at I, multiple column, MC at I, answer plus or equal to MR. Answer plus MC sum. Alright, I'm running out of time. Okay. Have a good day, guys. Bye.